Hello students, in last video we talked about the definition of a scalar and vector quantity. We defined a scalar and vector in last video. This video we are going to tell you how to represent a vector quantity. Representation of a vector has two methods. One is symbolic and second is graphical method. Let us talk about each one by one. So the question is here, how to represent a vector. There are two different ways. One is symbolic representation. We take a letter, it may be small letter, a lowercase, it may be capital letter or uppercase. Over the letter you can give an arrow or cap. The letter represents the magnitude and the arrow represents the direction of the vector quantity. In this way, we can represent a vector quantity in a symbolic way. The letter gives the magnitude, or the letter represents the magnitude part of the vector quantity, and the arrow or the cap will represent the direction of the vector quantity. This is a small letter. Over the small letter we can give a cap. A small letter. Over the small letter we can give an arrow or a capital letter, and we can give an arrow over it. In this way we can represent a vector quantity by using a symbol. This is what we call symbolic representation of a vector quantity. So an arrow or cap represents the direction. The arrow or cap represents the direction, and the letter itself represents the magnitude part of the vector quantity. So this is the symbolic representation of vector. Let us talk about graphical representation. How to represent a vector graphically. graphical representation of a vector. Let us talk about it now. For this purpose, let me draw a graph let me prepare a graph paper by drawing horizontal and vertical lines, or directly you can bring a graph paper. In the graph paper, this is the origin, this is y-axis, this is the x-axis. These are all the small divisions. Each small division or one small division can be taken as, say, 4 units. I am taking it arbitrarily. This is a scale, this is called scale. Each small division along x-axis and y-axis can be made equivalent to 4 units of a given vector. Let the vector be velocity. Say 20 kilometer per hour. So one small division is equal to 4 units. So we have 20 units, 20 kilometer per hour means 20 units. So in this graph paper, 20 kilometer per hour, that is equivalent to 20 units, is equal to 5 small divisions. This means that in this graph paper, if you take 1, 2, 3, 4, 5, this segment of the graph paper will represent the magnitude of the velocity vector. So the velocity of 20 km per hour can be represented by 5 small divisions of the graph paper along x-axis. Along x-axis is the east direction, along y-axis is the north direction. Velocity of 20 km per hour, but we have to mention the direction towards east. Towards east. This is the given vector. Our vector is the velocity vector of magnitude 20 km per hour and direction east. If this is the given vector, then direction is given by positive x direction, a positive x-axis, and the magnitude can be given by 5 small divisions taken along the positive x direction. So for the sake of simplicity, if you take the origin here, from the origin you have to take 5 small divisions in the direction of east or positive x direction, and the arrow should be given at the end of the segment in the direction of east, in the direction of positive x direction, or the positive x axis. So this is how we can represent this given vector in a graph paper. This is what we call graphical representation. So we can write the length of the arrow. We are getting an arrow here. So this is the arrow we are getting. In graphical method, with a proper scale, the vector can be converted to an arrow. This arrow has a length with the scale. This is the length of the arrow, and the tip itself gives the direction. The length of the arrow represents the magnitude and the tip represents the direction of the given vector. This is how we can represent a vector graphically, and this is the symbolic representation of a vector. This will form the basis of our next video, the unit vector.